Hi everyone, we are Team Copperajah. Our final project topic is the climate change. Climate change is a change in the pattern of the weather and related change in oceans, land surfaces, and ice sheets, occurring over time scales of decades or longer. Climate change can be realized with some effects: rising sea levels, increasing temperature values, extreme weather conditions, and increasing carbon dioxide emission rates. Our motivation to pick this topic is that this topic newsworthy and important for the future. Our motivation, this problem, is that decision would be taken according to the research on this topic will affect the future of many natural resources.
Hello, my name is Mehmet Emir SIRIKLI, and I will try to explain sea surface temperature. In this part, we use the sea surface file. Our dataset has three entries: annual anomaly, lower confidence interval, and upper confidence interval. Annual anomaly is given as the measure mean temperature, or lower and upper confidence interval is the limits of confidence. Annual anomaly should be between these two values. The other two are limits set by expert. It has annual anomaly has been many times our value is out of range. In the regression analysis, we use the linear and polynomial regression. We try to find the value could given an error rate lower than third degree. To find the lowest error rate, we print error value out to 19, and most suitable value is 85, as you can see. We only decide the annual anomaly in order to make machine estimation, and we saw the decision tree with more consistent linear prediction, but linear prediction is predicts the up and down moments correctly. We try to find the error rate using train test method, and error rate is dataset 0.9.
Hi everyone, my name is Ahmet. I have sea-level dataset, so let's continue with that. This dataset has two columns named by time and GMSL, as you see. By using this dataset, we have some conclusions. After that, to have more clear sight, we had a plot by using matplotlib. When you see the plot, there is an increasing situation, so it's a risk for the future. And then we see rise rates of sea level by using percentage change function, and we sort them by sort values function. So we have minimum and maximum values. Then on this graph, we look at the relationship between time and GMSL for regression. Let's continue regression. Linear regression is most useful for this dataset. We split the dataset named train and test. After the linear regression, the variance score is 98%. And here it's graph. As you see, it's linear.
Hi, I'm Büşra Nur SARIAKÇE. We examined the carbon dioxide rates emitted by the countries over the years. We get data from Data World Bank, and at this part we change our column names and we change data types to float, integer, and string. And here we made a plot which shows carbon dioxide emissions from the different fuel consumption. And we can understand from that plot that mostly solid fuels cause the carbon dioxide emissions, and lastly gaseous fuels. And because of the other dataset has lots of empty for Turkey, we use extra dataset which we get from Turkish Statistical Industry, and we made a plot especially for Turkey which shows total carbon dioxide emissions by the years, and there's with the type of which fuel, and there is a correlation between total carbon dioxide and the other features. And this pie chart shows countries with the highest carbon dioxide emissions over the years. There is a fact that China, North America, and United States emits more carbon dioxide more than all the other countries. And there's another plot which shows countries with the highest increased rate of carbon dioxide emission. And last but not least, we have other visualization which shows 5 different features at the same time, which is population, state, total carbon dioxide, and forest area, and country name. And the last, we made a regression. We use multivariable linear regression. And because of our dataset have lots of empty row and column, we clean our data. And we use dummies because we have category data, which is country name. Then we train and test our data. We get score of 0.99. And because of we have lots of column, we use dimension reduction with SVD. Then our score decreased to 0.19, but it's still okay. And the last, we made a plot which shows SVD1, SVD2 for SVD features and total carbon dioxide emissions.
Hi everyone, my name is Sadık and I will continue with the land temperature topic. For this topic, we have two different data sets. One of them is the global land temperatures, the other one is the land temperature by country. These data sets include dates and the average land temperature values. First, we got the years for the values from the issue of Y split for the minus sign. And we iterate over the columns, rows by the date column. After these calculations, we got this plot. By looking at this chart, especially after the 1900, we can see that the rate of rise temperature values increased considerably. We can say that after these years, the carbon dioxide emission rates increased dramatically because of the several reasons. For example, usage of solid fuels and the motor vehicles. After that, we did same calculations for the Turkey, specifically for the Turkey. By looking at this chart, we can say that Turkey's land temperature values rate of rise increased after 1900, but in contrast to the global average and land temperature values, Turkey's average land temperatures values are bigger than 10 degrees Celsius. This results probably takes its source from the mild climate conditions of Turkey. After that, we created linear regression models for data sets. First, we converted string dates to ordinal values. After that, we dropped some columns of the data set and filled the NA empty values by using fill NA method. Global regression model score is the 65%, and Turkey's we did the same linear regression steps for the Turkey specifically, and we got the 72% score of the Turkey's regression model. After that, we created the world map visualization for this land temperatures. By looking at this chart, average land temperatures values are represented on the world map. The colors from the blue to red shows the increasing of the temperature values, and according to this figure, Greenland has the lowest temperature rise between other countries, minus 18.58 degrees Celsius, and Djibouti has the highest degrees rate as the 28 degrees Celsius. These average land temperature values are average values by the years between 1714 and the 2013. Thanks for watching.